What's good, math family? In this video, we're looking at quadratic inequalities. We're going to focus on how to know which area to shade, as well as how to come up with the solution set and correct interval notation. When we have a problem like this, the first step we want to do is to identify the X intercepts. So we could set this quadratic inequality set to 0. So we go in, we're going to factor, we're going to get x plus 3 times x minus 1. And after we set both factors equal to 0, we're going to get x is equal to -3 for the first one. And the second one, we're going to get x is equal to 1. So when we go out here and we plot those points, these 2 points are going to be the most important because they kind of create that boundary line. So now that we know that, how do we determine where we're going to shade? Well, I got you. The first thing I would say is let's rewrite this so that this makes more sense to us. So once we rewrite this, we're going to say x squared plus 2x minus 3 is less than 0. So this is what we are interested in. When we plug in an x value, when are the y values going to be less than 0? And when we look at our graph and these boundary lines kind of separate the graph, meaning any x or any y outside or less than -3 is going to give us a positive y value, right? So imagine if we plugged in -4, all these values are positive for y. Same thing on this side. If we plug in any value greater than 1, the y values are going to be greater than 0. But in between our x intercepts, we notice what? Any x we plug in, right, such as let's say x is equal to -1, we know the y is going to be -4. So these are the values we are interested in. So typically, we could go in and we could just shade in the middle based off the explanation I said. But to improve your accuracy, always use a test point. So let's say we use the point 0, 0. So I plug it in, 0 squared plus 2 times 0 minus 3 is less than 0. So we're saying -3 is less than 0. This is a true statement, so we're going to shade in the area where that 0, 0 is. So after graphing the quadratic inequality, we know this is the area we would shade. Now, how do we express the solution set in interval notation? All right, it's going to be the same thing. So think about it. When are these values less than 0? So we're going to come up with a inequality that's going to be a compound inequality, and it's going to be similar to an and inequality. All right, so we know x is in the middle, and we know what? X is greater than -3, and x is less than 1. Those are the x values that are going to give us a y that's less than 0, and we know they are not included because it's of the sign, greater than or less than, open circle, right? So we know that. Now, if we express this in interval notation, we would just have parentheses, -3, put the comma, 1, and that's it for the interval notation. But before we go, smash the like button. This has been helpful. We're going to talk about what if this inequality symbol was greater than? How would that change our answer in interval notation? In this part of the video, we're now focusing on if the inequality had a greater than symbol. And matter of fact, let's put greater than or equal to symbol, right? How would this change our answer and the solution set? Well, for one, we're now more concerned with the y values that are either equal to 0, which are the solutions, or greater than. And we talked about it. So now if we're talking about greater than, that's going to be probably outside of our intercepts. So if I'm shading, I would now shade on the outside. Okay. And the way that we would express our answer when we think about it, we know that x would have to be less than or equal to -3, or x would have to be greater than or equal to 1. Those are the only x values that are going to work. These in the middle cannot work because they're going to give us values less than 0. So now we have the inequality, right? How can we express this in interval notation? Well, the same thing we did inequalities. So we know that graph is coming from numbers less than -3. So they're coming from negative infinity. It comes all the way up to -3. And because it's or equal to, that means 3 is inside that solution set. Use a bracket in union with, and where does the graph pick up? So after -3, this is not a solution. It picks back up at 1. Because 1 is included as well in the solution set, we're going to put a bracket around it. And all the numbers that are greater than 1, we're going to put infinity. And this would be the answer if it was a greater than or equal to. Really hope this video on how to know the correct area to shade for quadratic inequalities was helpful, as well as how to determine the interval notation, family. If it was, comment down below for us, smash the like button, and just let us know with comments if this video was helpful or if we need to put more videos out like this. Thank you guys so much for watching Algebra 1 with Mr. Peters.